Okay, for the example page, I'll tell you what you're looking for to decide if it is a function or not a function, and then we'll show an example. So, for ordered pairs, it is a function if x never repeats. Ordered pairs is a function if x never repeats. Okay, so we're going to do an example. So -2, 1, write it like an ordered pair in parentheses. 0, 4, 5, 3, -4, -9. Whenever y'all are working a problem and you have to decide if it's a function, you only need to look at the x's. So for ordered pairs, you should know that the x coordinate happens first because it lists the x number and then the y number. So that's the only part I have to pay attention to help me decide. I have -2, 0, 5, -4. The x number never repeated, therefore this example is a function. For a table, it is a function if x never repeats. So the example says 4, 6, 9, 7, -3, 8. So I only have to focus on my x numbers to decide if it is a function or not a function. I have 4, 9, -3. That x number never repeated. Therefore, yes, this example, it is a function. Okay, the mapping is the one that looks new. So, it is a function if one arrow leaves each number from the left. So mapping is just another way that they can represent ordered pairs. So we're going to have the mapping 2, 1, 3, 0, 4, but we're going to map it to this 1. So since that 1's already on this side, I don't have to rewrite it. And let's say 8, -2. Okay. So the first ordered pair that I said was 2, 1. So I just had to map that this 2 goes with that 1. So since there's only one arrow leaving this 2, this x only has that one y. The next ordered pair that I said was 3, 0. So I mapped those numbers together. And then I said 4, 1. So this 4 goes to that 1. It's okay on this side to have two arrows going to it. The important part is that it is a function if one arrow is only leaving each of these from the x side. This 8 only has this one output of a -2. So since this is a mapping, I know that it is a function if one arrow leaves each number from the left. 2 had one arrow, 3 had one arrow, 4 had one arrow, 8 had one arrow. Therefore, each of these x's does only have one y. So this is a function. Okay, there are already points on this graph, so I don't have to go and put random points. For it to be a function on a graph, so we need to say it is a function if each vertical line only touches one point. It is a function if each vertical line only touches one point, because whenever we draw a vertical line, we're only going to be touching the x-axis at that one number. So I'm going to start with this point right here. You draw a vertical line. You might need a highlighter. Whenever I drew this vertical line, I'm looking at the x value of -1, 2, 3, 4, 5. So I'm looking at all of the x values of a -5 to see how many y's does it have. And I only hit at this one y number, which is 0. So far, it's a function until I check the whole graph. On my next vertical line, so this is the x value of -3, it only has this one y value of a -2. My next vertical line, because there's a point right there, so this x value of a -2 only has this one y, whatever positive number that is. Now, the last points on the graph just so happen to lie on the same vertical line. So it is because of this that happened right here on that vertical line. There's more than one point. I'm going to say this is not a function. Okay, because whenever I did this vertical line, I wrote, well, this is really the equation x equals 1, because it's passing out a +1 on the x-axis. So it had a y of a 2 and a y of a -1, 2, 3, 4, 5 down here. So this x value did not have just one y, it has 2. Label it as not a function.